Hello, this is Professor Teresa Pelkie. This is Session 13, Part 2, Stored Procedures. In this video, we'll look at how to create and work with a stored procedure using MySQL Workbench. To get started, what are stored procedures? A stored procedure is an object in a schema. That means that it is created and becomes part of the schema, just like you create tables and views and they become part of the schema. A stored procedure contains one or more SQL statements. The statements are run when you invoke the stored procedure. You can define a stored procedure so that it will accept parameters when you invoke it. You are not required to define any parameters, or you can define as many parameters as needed. Each parameter has a name and a data type specified for it. The parameters that are passed to the stored procedure can be used with the SQL statements that are contained within the stored procedure. For example, you might have a select statement with a where clause in the stored procedure. You can pass parameters that will be used with the where clause so that you can vary the data that will be selected based on the parameter values. You'll see an example of that later in this video. You can put any valid SQL statements inside a stored procedure. Those statements include insert, update, and delete statements, which you'll learn about in the next session. If you use a select statement in a stored procedure, it returns a result set to the application that invoked the stored procedure. You'll see an example in this video. When you invoke a stored procedure in MySQL Workbench, the result set is returned and displayed in the result grid. So where would you use a stored procedure and why? Stored procedures are almost always used with an application. The application might be using any of the widely used programming languages. For example, Java, C#, Visual Basic, Python, PHP, and others. In many cases, the code that you develop for an application can be simplified by moving the SQL statements to a stored procedure. For example, consider a typical PHP web application that displays data from a database. The code for a PHP web page probably includes all of the following: HTML, JavaScript, PHP code, and SQL code. The issue is, each of those languages, HTML, JavaScript, PHP, and SQL, are significantly different from each other. To create a highly functional, resilient web application, you need to be proficient in each of those languages. The situation is really no different with other types of applications. For example, if you develop a web application using Java or .NET languages, you have the same issues of needing to be proficient in different skills. One way to simplify a multiple language application is to move the SQL code into a stored procedure. That way, the SQL is not in the application, but can easily be invoked by the application. In addition to making the code within the application easier to work with, a big reason to create a stored procedure rather than code the SQL directly in the application is that you can develop, test, and change the SQL independently of the application. If you get the SQL code working in a stored procedure, it will produce the same results when you invoke the stored procedure. Think about how this would work with a web application. If you code the SQL within a PHP page, and then you later need to change the SQL code, you need to change the PHP page itself, redeploy it to the web server, then run the web application just to test the SQL code. If you made a typo while changing the SQL, you will need to go through those steps again. Now, if the SQL was in a stored procedure, you could easily change just the stored procedure and test it using a tool like MySQL Workbench. If you don't change the stored procedure name or parameter list, you're done at that point. The application which was coded to invoke the stored procedure now invokes an updated version. Another reason to use stored procedures is that you may be able to reuse the code in your application. For example, it is likely that in an application, there may be several places where you run the same SQL statement more than once. For example, you may have an SQL statement to get customer or item data. Rather than code the same select again and again, you can code it once in the stored procedure. Another reason to use stored procedures is usually brought up by the database administrator or DBA, the person who is responsible for ensuring that the database is properly secured. Rather than allowing raw SQL statements to be directly run against tables and views, the DBA can configure the database so that users are not allowed to directly access the tables and views. Instead, all access to the tables and views is through stored procedures, which the end users or applications are allowed to invoke. That way, the DBA can review the code in the stored procedure before deploying it into the database. Once the stored procedure is deployed, the DBA can set the authorization for the stored procedure to allow or prohibit user and application access to that stored procedure. So let's see how you can create a MySQL stored procedure using MySQL Workbench. To get started, go to the navigator and expand the schema that will contain the stored procedure. Right-click the Stored Procedures item and select the Create Stored Procedure item as shown on the slide. Workbench responds by opening the New Procedure panel as shown on the left side of this slide. The Create Procedure template code is already entered for you. The first thing you need to do is enter the name of the stored procedure. Just type over the default name shown here as new_procedure. On the next slide, we'll go over some of the details about what's on this panel. Note that there are opening and closing parenthesis characters following the stored procedure name pointed to by the yellow arrow. In this example, we are not entering any parameters for the stored procedure. Later, you'll see how to define parameters by entering them inside the parentheses. The SQL statement or statements for the stored procedure are entered between the begin and end statements pointed to by the red arrows. This example shows one select statement in the stored procedure. The select statement is formatted so that the keywords and column names are aligned. Any formatting that you use is retained, so if you later go back and change the stored procedure in Workbench, you'll see the statements formatted as you originally entered them. You need to put an ending semicolon character after each complete SQL statement that is in the stored procedure, as shown by the green arrow. If you have more than one SQL statement in the stored procedure, each statement needs to have its own ending semicolon character. After entering the statement, click the Apply button in the lower right corner of the panel. The Apply SQL Script to Database panel is displayed. As you can see, there are some additional statements that are generated. If you are using Workbench, you don't need to do anything more. You can just click the Apply button on this panel to create the stored procedure. If you are creating and working with scripts but you are not using Workbench, you'll need to include the other statements in your script. For example, you might be using the MySQL command line tools to create a stored procedure. If you will be using the command line, you should review the statements that are shown on this panel and include the statements in the script file that you create. Now that you have a stored procedure, we'll see how you can run it using Workbench. After the stored procedure is created, go back to the navigator. You need to right-click the Stored Procedures item again. This time, click the Refresh All item as shown in the top corner of this slide. When you refresh the item, you'll see the newly created stored procedure. In the bottom figure, you'll see the Get Advisor's name, which is the name that was assigned to the stored procedure. Right-click on the stored procedure, then click the Send to SQL Editor, then click the Procedure Call item as shown in the bottom figure. The Send to SQL Editor procedure call opens a new editor panel. At the top of the panel, it displays a generated call statement, as shown at the top of the slide here. You can run the call statement by clicking the execute icon, which is the lightning bolt icon, the third icon from the left in the figure. When you run the call statement, the stored procedure is invoked. This procedure was defined without any parameters as indicated by the empty parentheses. The stored procedure runs and the results are displayed in the result grid. So the end result is the select statement that is embedded within the stored procedure runs. The results of the select are displayed. Using what you've seen here, you can see that one way to develop a stored procedure using Workbench is to first enter the SQL statement in the editor panel. You've seen a lot of examples of that in this course. Using the editor, you can quickly enter and run and change the SQL statement. Once you have a working SQL statement, you can use the Workbench Create Stored Procedure feature. Once the panel opens with the Create Procedure and Begin and End statements, you can just copy the SQL statement from the editor panel and paste the statement between the Begin and End statements. Now that you've seen the complete process of creating and running a stored procedure, let's compare a stored procedure to the other techniques that you've seen in this course. First, we'll compare a stored procedure to what I'll call raw SQL, which means an SQL statement by itself. In a stored procedure, all of the SQL statements are contained within the stored procedure. Now, by all of the SQL statements, I don't mean all of the SQL statements in your application. I mean all of the SQL statements that are used for that particular stored procedure. There might be one or there might be several. You can think of a stored procedure as being a named or saved query. Once you create the stored procedure, you can invoke it by its name. If you need to change the SQL, for example, to change the column list or the where or order by clauses, you need to modify and recreate the stored procedure. If you use Workbench, those tasks are easy. Workbench will reopen the stored procedure editor panel with all of the previously entered SQL code. You can then make the required changes and click through the editor panels to drop and create the revised stored procedure. In raw SQL, the SQL statement is processed individually. The statements that you entered in the Workbench editor panels cannot be invoked from outside of Workbench. If you need to run the statement in another application, you would need to enter the statement again or copy it from the Workbench and paste it into your application. Unlike the SQL code that is in a stored procedure, if you have an SQL statement in an editor panel, you can easily change the statement in place in the editor. As soon as you make the change, you can rerun the statement. Now let's compare a stored procedure with a view. First of all, both stored procedures and views are considered to be persistent database objects. That means that once you create a stored procedure or a view, it will remain in the database until you delete it. For a stored procedure, the first three items listed here were described on the previous slide. The fourth item shown here, cannot use where order by clause, means that when you use the call statement to invoke the stored procedure, you cannot put a where or order by clause immediately after the call statement. You can include a where or order by clause as part of the SQL statement that is contained within the stored procedure, but the where and order by are fixed or set in stone when you define the stored procedure. If you need to change the where and order by clause, you need to modify the stored procedure and recreate it. A view contains a single SQL statement, or it could contain a union type statement, which would have more than one select statement. Similar to a stored procedure, a view can be thought of as a named and saved query. Once you've defined and created the view, you don't need to enter the select statement again. You can just run a select against the view. Also similar to a stored procedure, if you need to change the results that are available from the view, you need to change and recreate the view. Unlike a stored procedure, you can use the where and order by clause when you use the view. For example, you can run a select against the view and immediately follow the select by both a where and order by clause. In some cases, you might be able to use a stored procedure or view interchangeably. In most application programming language, it is as easy to call a stored procedure as it is to run a select statement, and handling the result set is similar. It is very common when working with select statements to use variables in the where clause. For example, on a web page, a user might have entered or selected an item which would then be used in the where clause to retrieve data from a table. It will almost always be easier to invoke a stored procedure and pass parameters to it rather than build the where clause in the application. In many applications, you'll see that the developer uses a lot of string concatenation code to dynamically construct the where clause. When you see that type of code, it might be a good candidate to be replaced by stored procedure with parameters. You'll see that on the next slide. Here is an example of a stored procedure that uses parameters. In this example, there are two integer parameters. You can see the parameters inside the parentheses following the procedure name on line 1. The name of the stored procedure is Get Scholarship Awarded Within Range. So the parameter names are lower limit and upper limit. Based on the name of the stored procedure, you can figure out what the parameters are used for based on their names. Note how the parameters are defined for a stored procedure. The parameter name is first, followed by the parameter's data type. You see the lower limit and upper limit parameters used later in the select statement in the where clause. When the stored procedure is invoked, the values passed to the two parameters are used in the where clause. Now, just because you can pass a parameter into a stored procedure does not mean you can freely use the parameter value anywhere in the select statement. For example, you might think that you can create a general-purpose stored procedure by using a parameter for the table name in the from clause. Unfortunately, that doesn't work. Parameters for stored procedures are for use in the where clause. If you have a subquery, you can use the parameters in the where clause for both the main query and the subquery. Here is an example of calling a stored procedure and passing parameters to it. In this example, we are passing a range of 0 to 5,000, meaning that we want to see all of the scholarships with a value of up to $5,000. You can easily call the stored procedure again and pass in a more limited range to cut down on the number of rows that are returned. What happens if you call a stored procedure and pass it an incorrect parameter? For example, what if I entered the letter A for the first parameter rather than an integer value? The answer is the call was rejected. An error message is returned to the application. This brings up a very important issue that you may want to look into. The issue is called SQL injection, and it means that when you run an SQL statement that includes any values that are entered by a user, you need to be aware that malicious users can inject or enter code into your database using your SQL statements. One way to make it difficult for bad actors is to define stored procedure parameters as narrow as possible. This is particularly an issue with character parameters. For example, if you will be accepting character data as a parameter, find the parameter as a character data type with the minimal length that will meet your requirements. Rather than define a parameter as a character 100, define it as character 10 if that will meet your requirements. By defining parameters like that, if a bad actor tries to enter a long character string beyond the limits of the parameter length, the parameter will be rejected when the stored procedure is called. Do a search for SQL injection and become familiar with the issue. SQL injection attacks are one of the primary ways that bad actors attack a database, particularly if the database is used within a web application. In the next video, we'll look at SQL statements that modify the database and data contained in the database.